We are now going to talk about absolute value equations. Now, maybe or maybe not, you remember what absolute value means. So let's talk about the phrase absolute value. Absolute value. Well, first of all, let's look at the symbol, the notation for absolute value. We put straight vertical bars around something to mean its absolute value. And maybe you remember from an earlier lesson that if you put a number in here and you say the absolute value of 7, that's what this is asking you for, that is going to be equal to 7. And if you take the absolute value of -7, that's also going to be equal to 7. So what does absolute value really mean? Its definition is the distance a number is from 0. And so if you think about a number line and you imagine a number line with 0 here in the middle and the number 7 up here and the number -7 down here, when we talk about absolute value, what we're asking is simply how far is this number from 0? We don't care about the direction, whether it was positive or negative, just what's the distance. This is 7 from 0, and so is this. That's why they both equal a +7, because we're only measuring distance. We don't care about direction. Okay, so what happens when we start to put variables into an absolute value? You might be asked something fairly simple looking that looks like this. The absolute value of x is equal to 3. So what that really means is, if you're looking at a number line and you put 0 here, it's saying what number here has an absolute value of 3? Or stated otherwise, what number or numbers are 3 places from 0? So if we look at the number 0 and we say, what's 3 places this way and what's 3 places this way, we actually end up with 2 different answers, -3 and 3. So this equation, when you have an absolute value and a variable inside there, it often has 2 solutions. X could equal 3, or it could also equal -3. And we can check that by simply putting both of those values back into the equation and see if it's true. The absolute value of 3 is equal to 3, and the absolute value of -3 is also equal to 3. So both of these values check out. They both make it true. So this equation had 2 solutions. All right, well, let's look at ones that have a more complex expression inside of the absolute value. So let's say we have 2x minus 1, and that expression is inside the absolute value bars. Let's say that's equal to 5. Well, this isn't one that we can really sketch out on a number line and just figure out. So here's what we do. We want to look at just this part that's inside the absolute value bars. And we want to say, how could that thing end up having an absolute value of 5? How could this thing, 2x minus 1, have an absolute value of 5? Well, that could happen in 2 ways. One way is if this expression, 2x minus 1, was equal to 5. But it could also happen if that same expression, 2x minus 1, was equal to -5. If this entire thing inside here is equal to 5, then this is going to be a true statement. If this entire thing inside here is equal to -5, this will also be a true statement. So what we have is 2 separate equations, and they both have to be solved. So let's solve this first one. Add 1 to both sides, and we get 2x equals 6. Divide both sides by 2, and we get x is equal to 3. Over here, if we add 1 to both sides, this clears, and we're left with 2x equals -4. And dividing both sides by 2, we get x is equal to -2. And so what we end up with again, are two different solutions, x equals 3 or -2. And we could check both of those by substituting them back into the original equation and just making sure that it's true. I'll talk you through that. Let's pretend x is 3. 2 times 3 is 6, minus 1 is 5, and the absolute value of 5 is 5. With -2, 2 times -2 would be -4. -4 minus 1 is -5. And if you take that absolute value, it equals 5. There we go. Sometimes when we have an absolute value equation, it has other numbers that might be outside of the absolute value bars. So let's take a look at something like that. What if we have 5 times the absolute value of y plus 1 is equal to 30. So take a look at this and you'll see here's our equal sign. We've got absolute value over here, but we also have this number out front, 5 times this thing. So I will just let you pause and consider what might you do here? What do you think you might try? Now, many people, when asked that question, think, ooh, do I distribute the 5? Because it kind of looks like something you can distribute. But the answer to that is no. You can't distribute into an absolute value bars. Imagine these bars as like walls and we cannot penetrate them. What we have to do is find a way to get rid of this 5. And the way we get rid of it is think, well, this is multiplication, so we would do the opposite. We would divide by 5 and then divide by 5 on the other side of the equation. These 5s cancel out, leaving us with the absolute value of y plus 1 equals 30 divided by 5 is 6. Then we do what we did before. We've got our absolute value part isolated. We can break it into 2 separate equations and say y plus 1 is equal to 6, or y plus 1 is equal to -6. And then we solve both of those. We'll see that if we subtract 1, y could equal 5, and y could equal -7. So this answer, or this equation, again, has 2 possible solutions. So let me give you one to think about here. What if we have this? 2x minus 3, the absolute value of 2x minus 3 is equal to -9. I just want you to think about that for a second before you try something. What does absolute value mean? Let's go back way to the beginning. Way to the beginning. When we took absolute values of these numbers up here, 7 and -7, we always got a positive answer, 7 and 7. Because if we think about what the meaning of absolute value is, it's the distance from 0. So it's true then that when you do an absolute value, when you take an absolute value of anything, that can never be less than 0. It can never be negative. I shouldn't have put a 0 there. I should put like a variable, x, right? Absolute value of anything, whatever I put inside those absolute value bars, can never be negative. It has to be positive. So if I go back down to this problem we were working on, look at this. The absolute value of 2x minus 3 is equal to -9. Anytime you have absolute value bars with nothing else over here, nothing out here, or nothing over here, if that's equal to a negative number, that actually cannot happen. You can never take the absolute value of anything and get a negative number. So we say that in this situation, there is no solution. There's no solution for this. Okay, so let's look at a couple other situations that can occur. Sometimes you can have an absolute value on both sides of the equation, like this, 5x minus 8, with absolute value around that, equals the absolute value of 5x minus 12. So what do we do here? kind of the same thing, that we did before. We take our expression in this absolute value and we say, all right, 5x minus 8 can equal whatever this one is, 5x minus 12. Like that is one possibility. Another possibility, bring it way over here, would be if 5x minus 8 equals the opposite of this. So kind of like we had to make it negative, we're going to do the same thing here, but it's an expression that has two terms. So we have to change both of the signs of both of the terms. Or the best way to do it is really say negative, the opposite of, and then put the entire expression in parentheses. So it's the same two equations, but one we're just going to take the opposite of. Let's see what happens here. On the first one, something interesting happens here. If we subtract 5x from both sides, this happens to be a situation where both terms with variables cancel out, and all we're left with is this statement, -8 equals -12. You might remember from earlier, another lesson, that anytime your variables cancel each other out in an equation, you have to look to see whether the final statement is true or false. And in this case, it's false. That -8 does not equal -12. So this one gives us no solution, right? This does not give us anything. There's no solution for this equation. On this case, that doesn't happen. In this situation, we have 5x minus 8 equals, we're going to distribute this negative to both of those signs, -5x, and then this becomes plus 12. And then when we solve it from there, we would add 5x to both sides, giving us 10x minus 8 equals, this is gone, so equals 12. We would then add 8 to both sides, 10x equals 20, and divide by 10. X is equal to 2. So this one only ended up with one solution, even though it was an absolute value equation.